Mathematics 2, June 2015 examination. Question 7. A company makes pistons for car engines. The pistons cost £10 each to manufacture and they're sold for £25. If the supplied pistons are outside the design spec, the company has to buy them back at £30 each. Piston diameters are normally distributed with a mean diameter of 64 mm and a standard deviation of 0.5 mm. The design spec for piston diameters is 64 to 65 mm. How much money will the company make from a batch of 1,000 pistons? The cost of manufacture of 1,000 pistons is 1,000 times £10. The income from selling 1,000 pistons will be £25 times 1,000. So that's £25,000. So the profit from 1,000 pistons will be 25,000 minus 10,000 is £15,000. Let's look at our scrap rate. Piston diameters are normally distributed with a mean diameter of 64 mm and a standard deviation of half a millimetre. This is the mean, this is one standard deviation. So this is 64 and this is 64 plus a half. This is the mean. One standard deviation is a half, two standard deviations is 1 millimetre, minus one standard deviation is minus a half a millimetre, and minus two standard deviations is minus a millimetre. Now, if we think about the design spec, the pistons lie between 64 and 65. So that means the green area meet the design specification, which means that the red area is scrap. 34 and 14 is 48. 48 from 100% gives us 52%. We have 52% scrap. 52% of the production is scrap, and the buyback price is £30 per item. The number of scrap items is going to be 52% of 1,000, which is 520. The cost of that is going to be 520 times £30 each, which is £15,600. If we subtract 15,600 from our profit, we end up with a net loss of £600. Part B. If the company adjusts the equipment that makes the pistons so that the mean is 64.5, how much money would the company make on the same batch of pistons? The company now adjusts the equipment so that the mean diameter of the pistons is 64.5%. So watch the 64, that becomes 64.5. So now 64 to 65 is plus or minus one standard deviation. So the acceptable pistons are the green area and the scrap is now the red area. 34 plus 34 is 68%, which means that we've got 32% scrap. So the number of scrap items is 32% of 1,000, which is 320. The cost of the scrap is 320 times 30, which is £9,600. If we subtract that from 15,000, we're going to get a net profit of £5,400. Part C. In addition to adjusting the mean to 64.5, the company also reduces the standard deviation from 0.5 of a millimetre to 0.25 of a millimetre. In addition to adjusting the mean to 64.5 millimetres, the company also reduces the standard deviation to 0.25 of a millimetre. So watch what happens now. The population now lies between plus and minus 2 standard deviations, which means that the acceptable pistons are the green area and the scrap is the red area. And this time the scrap is only 4%. 4% of 1,000 is 40. 40 pistons at £30 a piston is £1,200. 1,200 from 15,000 gives us a net profit of 13,800. Part D. Why do we think our answers are correct? Well, if we look at the drop in scrap rate from 52 to 32%, we have a rise in profit of £6,000. And if we look at the drop from 32% to 4%, we have a rise in profit of £8,400. This is 20% change, and it gives us £6,000 profit, so that's £3,000 for every 10%. This is roughly 30%, and that's roughly £3,000 for every 10%. So that means we have a model that is consistent across the two values, and therefore we can have a reasonable confidence in the figures that we've generated. And that's the end of question 7.